Hello, our project title is Automatic Speech Recognition for Disabled People.
In today's world, technology has made communication much easier than before. Unfortunately, there are some who still struggle to communicate due to disabilities. Our team embarked on a project to make communication accessible to nonverbal, deaf, blind, and deaf-mute individuals.
For non-verbal individuals, we will integrate a sign language to speech with emotions feature into the app, which converts the sign language into audio. For deaf individuals, the app displays the transcribed text in real time. For blind individuals, we added an assistant feature that can recognize sounds and return an alarm. The app also has a feature for deaf-mute individuals that allows them to communicate using sign language. The app uses a machine learning model that can convert sign language gestures into text. In addition to the features that we mentioned before, we have also added a chatbot feature that allows non-verbal, deaf, blind, and deaf-mute individuals to communicate through a text-based chatbot. This feature can be useful for individuals who prefer text or speech-based communication. They can easily communicate with the chatbot using the text or speech input, and the chatbot can respond with text or voice output, depending on the user's preference. Our team believes that this chatbot feature will enhance the accessibility of our application and provide an additional means of communication for non-verbal, deaf, blind, and deaf-mute individuals.
In 50 years, the world could be a vastly different place with the potential to be more connected, technologically advanced, and environmentally conscious.
Developing an automatic speech recognition system for disabled people requires advanced technologies that can work seamlessly together. Our team used four main platforms to develop our system. First, we used OpenCV, an open source computer vision library, to help us extract frames from the videos. This allowed us to analyze and process video data more efficiently, which was crucial for generating our own dataset and developing our machine learning model. Second, we used PyTorch, an open source machine learning library, to develop our own machine learning models. PyTorch is known for its ease of use and flexibility, which made it an ideal choice for our project. Third, we used FastAPI, a modern web framework for building APIs, to integrate all our models into APIs. FastAPI allowed us to create high-performance APIs that could handle multiple requests and responses in real time. Finally, we used Flutter, an open source mobile application development framework, to develop our own mobile application, which allowed us to create a beautiful and responsive user interface that could be easily integrated with our APIs. With Flutter, we will be able to deploy and test the performance and the efficiency of our developed model. By using OpenCV, PyTorch, FastAPI, and Flutter, we'll be able to develop an innovative and effective system that can help people with disabilities communicate with the world and their surroundings. Our team is proud of the technologies we use and the impact we are making on people's lives.
The system will be applicable in a wide range of situations, including healthcare settings, educational environments, and social interactions. For example, a deaf individual could use the system to communicate with their doctor during a medical appointment. Or a blind person could use it to order food at a restaurant.
For the social impacts, our project can help improve communication for people with disabilities, which will enhance their social interaction with others and reduce the feeling of isolation and exclusion from society. Additionally, our project can have a positive impact on the families and caregivers of people with disabilities. Communication can be a major challenge for those caring for someone with a disability, especially if they are not familiar with sign language. By providing a tool that facilitates communication, our project can make it easier for caregivers to provide care and support to their loved ones. Our project aligns with Sustainable Development Goal number 3, Good Health and Well-being, as it helps individuals with disabilities communicate more effectively and interact with others, thus promoting their mental and emotional well-being. Additionally, our project aligns with SDG number 10, Reduced Inequalities, as it aims to provide equal access to communication for people with disabilities and reduce the communication barriers they may face. Our project can make the world more accessible for people with disabilities. For example, the sound recognition module can help deaf or blind people be more aware of their surroundings and help them navigate the environment more easily. For the industrial impacts, there is a significant market demand for technology that assists people with disabilities. By developing a product that meets this demand, our project can create a new market niche and potentially generate significant revenue, thus creating new job opportunities and promote innovation in the technology industry. Increase potential partnerships and collaborations with organizations that work with people with disabilities, such as disability rights groups, healthcare providers, and assistive technology companies to further develop and improve our technology and expand its reach. The project can also improve the accessibility of other products and services, such as websites, software, and public transportation, leading to more inclusive and accessible environments for people with disabilities. Also, we can license or sell our technology to other companies or organizations that want to incorporate it into their product or services, creating a new revenue stream and potentially increasing the impact of our project on a larger scale.